Okay, welcome friends. We're going to relate f and f prime. I'm going to do this in a kind of exaggerated way in case you're really struggling with this. So look very carefully. This graph right here, the black one that is, that's our position, our f, our function, okay? Now notice something very specific, right below me right there. If I was standing there, what would be going on? Well, imagine I'm standing there. You see it's level. Now imagine what I do is I travel along the curve. I'm traveling up a hill. I reach the crest of the hill, and then I travel down the hill to the other side, like this. But there's definitely a location, the one directly below me, where it's horizontal. What does that tell you about the behavior of f prime, for example? So f prime is the green graph. Look very carefully down below at f prime. Notice that to the left of this value right there, f prime, as you can see, is a positive quantity. That means that the original function has a positive slope, as I've said. The fact that this is above the horizontal axis and the values are positive, look very carefully right here, that tells you you're climbing up a hill like this, you see? But it's telling you more than that. Let's look very carefully. Look at the behavior of f prime, say, focus only on this little dashed rectangle so it's more focused. Notice that here, the value of the y-coordinate on f prime is pretty big, right? It's whatever that is. And then as you approach this location, the value of the y-coordinate on f prime goes to 0. So what does that tell you about the behavior of the function f? Well, it's telling you because here below me the y-coordinate is pretty big. That tells you the original function, as you can see, it's talking about this. That's telling you it's pretty steep perhaps. Again, look very carefully, right? The fact that f prime or y prime is almost 0 right here. It's very small. It's still positive, right? But it's very small, like maybe 0.1 or something. That tells you that over here on this graph, the slope is very gentle now. So there's a very tight coupling between these two graphs. Okay. Okay, again, look again what happens to the right of this. So this is a negative number now. But in absolute value, it's pretty small still, right? So that means on the graph of f, right there, the graph is now going down, but it's still pretty gentle in terms of the slope. But then, look here. At the y-coordinates, say, at this location below me, whatever that y-coordinate is, I'm not even sure, it doesn't really matter. The point is that the y-coordinate on the graph below me here is more negative than the y-coordinate is in this location below me, at this location, you see? So because this y-coordinate below me on the green graph is more negative, that tells you that on the original function, right there, you see, it's more steep. So for example, here it's more steep, like directly below my chin, it's more steep, right, than directly below my chin right here, okay? So that's the tight coupling between these. Now let's do this on the other side. Let's focus, say, on what happens within this red dashed rectangle only. So I could just hang out right there, right, in this trough, so to speak. The y-coordinate there is whatever it is, not important. What does matter, though, is that it's clearly horizontal. That's like saying that y prime is equal to 0. Okay, so let's look at the graph of y prime directly below that location, right there, as I've said. You see, the green line is y prime, and as you can see, its y-coordinate is equal to 0. That tells you that an original function right there, this is horizontal, as if you could hang out in that location, staying there. Okay, but now go back here again. Look very careful, right? So at this location, directly below my chin, look there, okay, so it's kind of focused. You can see that the y-coordinate there is a negative quantity. That tells you that in an original function right there above me, that the slope is negative, and you see that because you're going down this hill. It's a negative slope. Okay, again, let's go back here to this location. Directly below my chin, roughly speaking, you see that the y-coordinate and f prime is a positive quantity, isn't it? That's telling you that here on f, right there in this location, you're going up a hill. Okay, the graph is going up. That has a positive slope. But again, there's more than that. So what is the more than that? Look at the following fact. Right here, directly below my chin, roughly speaking, there's a positive y-coordinate on f prime. On the other hand, here, there's also a positive y-coordinate on f prime. Except the positive y-coordinate on f prime here is much bigger, right, than it is right there, below me. That tells you that the original function at this location where I'm right now, the original function at that location is much steeper than it is at whatever the location is here. That's what it's telling you. Okay? So it's not only that it's switching from negative to positive, but it's also than the behavior of the y coordinates in f prime, telling stuff about the behavior of f. Right? And you see this here because if you look at it, right, below me directly, it's a positive slope, but it's pretty gentle, right? Whereas on the other hand here, there's a positive slope, but you can tell it's already bigger, it's steeper. So that's reflected in the values of the coordinates of y prime. So that's it for this one. I hope it's helpful and insightful. I like this graphical approach to exploring things really at the very deep intuitive level, so to speak. Please leave a like and subscribe and check out the other videos on this channel.